Chapter 6, Section 3, continuing with the matrices. This part here is multiplying matrices. And so what you need to remember is the row by column. Remember that phrase, row by column, because it is a row by column computation that is performed when you are multiplying matrices. So again, perform a row by column computation. Now remember, rows go across and columns go up and down. Also, memorize whatever it takes to help you to remember it's always row first, right? When you find the order of a matrix, it's always row by column. When you're trying to find something like A sub 5, 2, it's always the 5 is the row, the 2 is the column, right? It's always row by column. So remember the little song, row, row, row your boat, so that you can remember that it's row first, okay? So whatever it takes. If that doesn't help you, the little row, row, row your boat, then think of something else to get you to remember. It's row by column, rows first. Do not multiply corresponding entries, okay? We added and subtracted corresponding entries when we were adding and subtracting matrices. But matrix multiplication is different. You cannot multiply corresponding entries of those matrices. So definition of matrix multiplication. So we'll go through a little abstract representation, I guess, if you will, of what this is going to look like. So I've got, here's big A, big B being multiplied together, and that's matrix A and B. And so this matrix here, it's a 2 by 2. This is a 2 by 2. And we can multiply a 2 by 2 with a 2 by 2. We're going to talk about what the product of these matrices look like. If you were in class, I prefaced this a little bit with some of you. And so what you're going to do and how you're going to approach this is you're going to multiply the row with the column. So right here, I'm going to multiply A with E, and then you add, and then I'm going to add B with G. Okay, so it's A times E plus B times G. AE plus BG. This seems a little tight in here. All right, so this is first row, first column. So I multiply the first row with the first column. Now I need the first row with the second column. That's A times F plus B times H. All right, second row, first column. That's C times E plus D times G. And now I'm going to do second row with second column. That's C times F plus D times H. Now, it sometimes looks confusing, but, think of it as you're multiplying the first in the row with the first in the column, the second in the row with the second in the column. Okay, so that's where your corresponding idea comes into play with multiplying matrices. It's row by column, and then it's firsts, seconds, thirds, fourths, fifths, depending on how large the matrices are. Now, if you also notice this position here in the matrix, okay, once I find those two products and add and get that single value, this right here is really in row 1, column 1 of the matrix. And so that's why I'm multiplying together row 1 with column 1, right? A with E, B with G. That's that sum there. Okay, and in a, similar fashion here, I could just box all of these off. Because there are 4 entries in my matrix. So this is row 1, column 1. This was found by multiplying, well, let's look. This is in the first row, second column. So I'm going to multiply row 1 with column 2. And this entry in the output, the final matrix, is row 2, column 1. So it makes sense I'm going to get it by multiplying row 2 with column 1. And then finally, this entry, which is in row 2, column 2, that would come about by multiplying row 2 with column 2. Okay, and double check it again. Row 2 with column 2 would be C with F, D with H, and that's what that says there. And you add the products after you compute them. All right, so let's look at this example. Now, I'm going to want to see in your homework the setup. I'm sorry if you don't have it. I can't give you credit for the homework because the answers are in the back of the book. Okay, so please just either write everything out or at least write something out. I'm going to show you, especially when these matrices get larger, you know, if you're doing like a 4x4 with a 4x4, there's lots of multiplications that go on in there. All right, so I see this is a 2x2 and this is a 2x2, and I'm expecting what's coming out as a 2x2. So I'm going to leave spaces for my 2x2. And this is in the output matrix in row 1, column 1. So I'm going to multiply row 1 with column 1. That's 1 times 4 plus 3 times 1. Now I'm going to do row 1 with column 2, right? Because this is in row 1, column 2. So row 1 multiplied with 6 plus 3 with 0. Right? You go across the row and you go down the column when you're multiplying. This here, this is row 2 with column 1. That's going to go here. 2 with 4, 5 with 1. 2 with 4, 5 with 1. Now, you should see a little pattern here. The stuff in the parentheses, they should all match. Okay, so if you set it up, you're going to be able to tell if you set it up right or if you did not set it up correctly. All right, this entry here is in the second row, second column, so I'm going to multiply the second row with the second column. 2 with 6, 5 with 0. 2 times 6 plus 5 times 0. There we go. It's set up right. There's 6's in there, and there's 0's there. So I'm looking here on the outside, 1, 3, 2, 5, 1, 3, 2, 5. And then on the inside of the parentheses, 4, 6, 1, 0. Right, those are my 4's. I mean, these are my 4's, these are my 6's, these are my 1's, those are my 0's. All right, let's perform these computations now. 4 times 1, 4, plus 3 times 1, 3. 4 and 3 is 7. 1 times 6, 6. 3 times 0, 0. 0 plus 6 is 6. 2 times 4, 8. 5 times 1, 5. 8 and 5 is 13. 2 times 6, 12. 5 times 0, 0. 12 and 0 is 12. Okay, and this is my final answer after I multiply the matrices together. Now, these are going to get quite large. And so the more organized you are, the better it's going to be. So if you have questions on that, please ask. Come into a Google Meet or ask in class. And now I'm going to move on to scribe. Sorry about the paper shaking here. What the product of an M by N matrix with an N by P matrix is. All right. So we saw when we were adding and subtracting matrices that the order had to be the same. Well, when we're multiplying matrices, the insides here, okay, meaning M by N and N by P, notice the N is exactly the same. So when I multiply an M by N with an N by P, my output is going to be an M by P. Now, realize when we're multiplying matrices, you're not going to have M's and N's and P's, okay? They're going to be numbers, like a 2 by 2 with a 3 by 4, okay? So the outside ones is the output size matrix. these on the inside, they must be the same or you cannot multiply. Must be the same. Okay, or the dimensions are going to be mismatched. You're not going to be able to multiply them. So the product of an m by n matrix with an n by p matrix is an m by p matrix. All right, example 6 says if A is 2, 0, 4 and B is 1, 3, 7, find A times B and B times A. First, write the output of each product. You know, first you want to know, is this something that can be done? Well, let's see. A, first of all, what is the order of A? A has, remember it's always row first then column. It has 1 row by 3 columns. What's the order of B? Well, B has 3 rows by 1 column. Folks, the inners do match. What's my output going to be? My output is going to be a 1 by 1. All right, the output's going to be a 1 by 1. Yes, a 1 by 3 with a 3 by 1. Output is going to be a 1 by 1. So I'm going to write A times B equals, and I'm going to write matrix A to the left. I would like you to do this in your homework as well when they're asking you to find A times B and B times A. I want to see the setup, meaning whichever's on the left, that's the matrix I'm going to want to see on the left in your work. 1, 3, 7. All right. It's a row by column multiplication. I've got 1 row and 1 column. That's it. So what's going to end up happening is it's going to be the first with the first, 2 times 1, plus second with the second, 0 times 3, plus third with the third, 4 times 7. And now I'm going to do the computation. 2 times 1 is 2. That's 0. 2 plus 0 is 2. 7 times 4 is 28. When I add the 2 with the 28, I get 30. And there is my 1 by 1. So the product of A and B equals this matrix right there. Oop. That matrix right there. All right, now let's take a look at with a different color. We'll take a look at B times A, B times A. Well, B is a 3 by 1, and A is a 1 by 3. Folks, I can multiply this. I'm going to end up with a 3 by 3. I know it doesn't seem possible, but we are going to end up with a 3 by 3. So I'm going to set up B times A, and this is what I meant by in the homework that I'm going to want to see, you know, that if it's B times A, that you have matrix B to the left of matrix A, like this. All right, we are expecting a 3 by 3. So it probably will benefit you to write a matrix, right, or at least the brackets, and put some lines in here to create a 3 by 3. Understand? So here's 1, 2, 3, 1, 2, 3, 1, 2, 3. This is a 3 by 3 matrix. So I'm setting up for my workspace. This entry up here comes from, it's in the first row in the first column. Row 1, column 1. This one here is row 1, column 2. This one here is row 1, column 3. And so you're going to take those entries in row 1 and column 1 and multiply them. Row 1 has a 1 in it. Column 1 has a 2 in it. That's all I could do because those are the only entries in the rows and columns. This element in the matrix is found by multiplying row 1 with column 2. So that's this entry right here, row 1 with column 2, 1 times 0. Now notice we're not adding any products here because there aren't any more elements to multiply, right? Because like in this row there's only one element, in this column rather there's only one element. It's only going to have one product. All right, the row 1 column 3 is 1 times 4. All right, here, what do we got? Well, this is row 2 column 1. Right, row 2 column 1. So I'm going to take the entry in row 2 and multiply it with what's in column 1, 3 times 2. This is row 2 column 2, or 3 times 0. And this is row 2 column 3, or 3 times 4. Now notice I'm seeing a pattern of that stuff inside the parentheses. So it's another reason why I want you to set up and show the work this way. It just makes it easier for you. All right, this is row 3 column 1. Row 3 with column 1 is 7 times 2. Row 3 with column 2 is 7 times 0. And row 3 with column 3 is 7 times 4. And now we have to clean this up. And we see 1 times 2 is 2. That's 0. That one's 4. 6, 0, 12, 14, 0, and 28. Final answer. Okay, so if you have questions on that, please let me know so I can help you. Again, the more work that you write and show, it's going to be easier for you to accomplish this task. Now, down at the bottom of the page, it says, is matrix multiplication commutative? Right? Basic multiplication is commutative, right? 2 times 3 equals 3 times 2. But is matrix A times matrix B equal to matrix B times matrix A? And when we look at the outputs, we have to say no, absolutely not. Okay, so you can't just find A times B and assume B times A is the same. It is not with matrix multiplication. Okay, the next part of this is example 7 on the next page. And it says, where possible, find each product. Well, folks, you have to determine the order of the matrices so that we can make a determination if they can or cannot be multiplied. This matrix here is 2 rows, 2 columns. This is a 2 by 2. This here is 2 rows, 1, 2, 3, 4 columns. Can we multiply? We can, because these two match. What is the output? Well, the output is a 2 by 4. Let's check the second one, part B. This is a 1, 2 by 4. This matrix is a 2 by 2. Now notice these do not match. So when they do not match, you cannot multiply them. So I'm not worried about part B here at all. That's impossible. So all I'm going to do is worry about and focus on my part A multiplication matrix. Now I know the output is a 2 by 4. This is 2 rows and 4 columns. So I'm going to write my matrix brackets wide. And sometimes you might want to do these problems on, unlined paper and do the landscape. It makes it easier. All right, so I know there's 2 rows and I know there's 4 columns. Okay, so there's my 2 rows, top and bottom, and my 4 columns. And I'm going to set up for my showing of my work. Now remember, this is row 1, column 1 here, so I'm going to multiply row 1 with column 1. First with the first, second with the second. 1 times 2, 3 times 0. 1 times 2 plus 3 times 0. Row 1 with column 2. First with the first, second with the second. 1 times 3, 3 times 5. 1 times 3 plus 3 times 5. Row 1, column 3. Row 1 with column 3. First with the first, second with the second. 1 times negative 1 plus 3 times 4. All right, row 1, column 4. Row 1 with column 4. First with the first, second with the second. 1 times 6, 3 times 1. All right, I've exhausted row 1. Now I'm going to look at row 2. Row 2 with column 1. 0 times 2, 2 times 0. Row 2 with column 2 is 0 times 3 plus 2 times 5. Now, notice how these are getting set up. And folks, when these get busy, I just kind of like look at the actual row, and then I copy the column from here. So it's like I got 0 times what? Well, that's negative 1 plus 2 times what? 4. Okay, I know it's going to be there. Okay, and then I go, all right, this row, 0 times what? 6 plus 2 times what? 1. Because the stuff in the parentheses is going to be the same. And now I'm going to actually perform these computations. This is 2, that's 0. When I add them, I get 2. This is 3, that is 15. When I add them, I get 18. This is negative 1, this is 12. When I add them, I get 11. This is 6, this is 3. When I add them, I get 9. This is 0, that's 0. When I add them, I get 0. That's 0, that's 10. When I add them, I get 10. That's 0, that's 8. When I add them, I get 8. That's 0, that's 2. When I add them, I get 2. Final answer. And of course, there it is. I think you knew what I was doing in writing. All right, so remember, when these matrices get bigger, you know, if you have a 4x4 with a 4x4, you're now going to be having 4 products to write. And they just get busy. They're not difficult. They just get a little busy. But if you're organized, it's so much better. So if you have questions, please ask in class or on the Google Meet. And we have some days this week, if you look at the calendar, for practicing with matrix multiplication. You do have an assignment. It's on the calendar. It's on the agenda. Have a great day.